Now, first we need to discuss what is thermodynamics all about. And I have to say this is one of the most powerful topics that you will ever explore. Thermodynamics is a study of transferring energy, obtaining energy, transferring energy, and applying energy. So you can see all sorts of applications of energy transfer around you. And we'll develop skills and analytical tools that allow us to understand and quantify those systems. So to be very specific, we're going to talk about topics of mass and energy conservation principles. We'll look at first law analysis and as they apply to open and closed systems. We'll investigate and define properties that allow us to explore these systems. And we'll look at the behavior and application of specific thermodynamic systems at steady state conditions. The concepts of state relations and conservation principles. We're going to teach you how to quantify the state of simple, pure substances, including all three phases, solid, liquid, and gas phases. I'll teach you how to evaluate energy, work, and heat transfer processes and how those processes interact. We're going to investigate the conservation laws for mass and energy systems, and we'll apply those to example systems so you can have some understanding, particularly for stationary and transportation power sectors. What are the units involved, what are the numbers involved, quantities, and scale. And we'll teach you the application of process knowledge to analyze complete systems. So after taking this course, you should be able to identify subsystems. You should be able to indicate whether or not there's work transfer, heat transfer, and what's the importance of the thermodynamic state for those systems in terms of temperature, pressure, density, and other thermodynamic variables. Given a set of properties, you should be able to identify the phase and the remaining properties for a substance. If I give you a physical setup, for example, if it's an engine, a jet engine, or if it's a stove, you should be able to determine what are the work and heat transfer mechanisms and what are the most reasonable approximations that you can make to analyze the system. Once you have that physical setup, the device, and the process, you should be able to compute, to quantify the rates of work and heat transfer as well. You should be able to formulate an ideal approximation as well as understand how an actual system might differ from an ideal system. And given an actual device, you should be able to correspondingly create an ideal device. So we can have both real and actual systems, and we should understand quantitatively what are the differences between real and actual systems. Use some references and tools that are freely available on the internet. So those are listed here on this slide. The first is the U.S. Department of Energy Fundamental Handbook on Thermodynamics, Heat Transfer, and Fluid Flow. In reality, there are 3 handbooks here in this series. We're only going to use the thermodynamics portion of that set. There's a Thermodynamics and Chemistry second edition that was written by Howard DeVoe. He provided that textbook free on his website, and that link is shown here. And the third resource that we'll use is an online calculator for steam, in other words, water, properties, which includes also properties for carbon dioxide and ammonia. There are many online calculators that are available to you. This just schedule. So all the reading material is from those 2 reference texts, the U.S. Department of Energy Thermodynamics Handbook and the Thermodynamics and Chemistry Handbook by Professor DeVoe. So the chapters and reading pages are listed here. Schedule. So all the reading material is from those 2 reference texts, the U.S. Department of Energy Thermodynamics Handbook and the Thermodynamics and Chemistry Handbook by Professor DeVoe. So the chapters and reading pages are listed here, and the topics are listed here that we'll be going through throughout the 8 weeks of this course. We're going to start with the basics. So we need some tools in order for us to analyze these thermodynamic systems, these energy transfer systems. And that includes concepts, definitions, and once we have that information, we can start defining thermodynamic properties. And in particular, we'll look at how we can measure temperature and pressure, how we can describe the states of different systems, and processes and pathways that connect us to different thermodynamic states. After that, we'll discuss the energy of a system, the first law of thermodynamics, which is the conservation of energy, heat and work transfer, energy analysis of closed and open systems, and how those energy transfer systems use energy, enthalpy, and internal energy. And that will be it. We'll do many examples throughout the class so that you have some idea of how to apply these tools. And this reading material is really meant to support the lectures and the content that we have right now that we provide in these lectures. Some frequently asked questions. We'll try and answer those right now. What are the prerequisites for taking this class? You should have some introductory background in chemistry and physics and calculus. This is going to be important for understanding some of the thermodynamic principles, and the calculus is necessary for some of the analysis that we do. Specifically, you should understand how to integrate or differentiate an equation. Transfer, internal combustion engines, stationary power generation, propulsion, and gas dynamics are just a few classes that build on the foundation we will establish in thermodynamics. In the real world, energy is one of the top challenges we face in a global society. We know that energy demands are deeply tied to the other major challenges, which include poverty and health and clean water. And understanding how energy systems work is key to understanding how to meet global needs for energy. And because energy demands are only going to increase. Now, based on what we just briefly talked about, how thermodynamics is the study of energy, transforming, applying, obtaining energy, I'd like you to pause for a moment and look around you, or maybe look out the window, and identify 5 systems where you think energy and energy transfer mechanisms are important. And when we come back, we'll discuss a few of those examples. Thank you and welcome to the class.